Good morning, student. Today we will start with chapter number 8 of your textbook, that is quadrilateral. So basically, what is a quadrilateral? So a quadrilateral is a figure that is having four sides, four angles and four vertices. This is the definition of a quadrilateral. A quadrilateral has four sides, four angles and four vertices. See, this is your figure. In this figure, you are having four sides, that is side AB, BC, CD and AD. Then you are having four angles, that is angle A, angle B, angle C and angle D. Again you are having four vertices, that is A, B, C and D. What do you mean by vertices? Vertices means the corner points which is joining by two line segment. A corner point which forms by two line segment, that is known as a vertices. Okay, so this is the definition of a quadrilateral. Next, after in your textbook it is the angle sum property of a quadrilateral. Now how you will use angle sum property of a quadrilateral? See, you had studied about angle sum property of a triangle. Now if you will say what is the angle sum property of a triangle, suppose we are having a triangle A, B and C. So what is the angle sum property? So that is angle A plus angle B plus angle C will be equals to 180. This will give you 180. This is the angle sum property of a triangle. Now for quadrilateral, what we will do, we will make a quadrilateral. Suppose I am making a quadrilateral this way, quadrilateral A, B, C and D. And suppose if I am taking a diagonal in this quadrilateral, that is diagonal AC over here. Okay, so what is now happening here, that this diagonal has divided this quadrilateral into two triangles. First is triangle ABC and second is triangle ADC. Okay, so now we are having two triangles. So now you know what is the angle sum property of a triangle. So that is 180. So here for triangle ADC, if I am talking about, angle A plus angle D plus angle C will be equals to 180. And if we talk about angle ABC, triangle ABC, so there is also angle A plus angle B plus angle C, that is also equals to 180. Okay, but here what is the theory is, here we are having both the triangles in a quadrilateral. So now what we have to do, we have to add both this triangle to get a quadrilateral. Okay, so I am adding both these triangles. So when we add all these triangles, we must get a quadrilateral, and the total of all this will be, see how addition is possible. Now when you are doing addition, at that time you have to do left hand side addition, left hand side, and right hand side addition, right hand side. So here we are having on left hand we are having angle A plus angle D plus angle C plus triangle ADC plus angle ABC will be equals to 180 plus 180. I am doing this way. I am not adding all the angles because that will be 2 times then. Okay, so this way we will be doing. Now ADC plus, say these are the triangles, not the angles. So triangle ADC plus triangle ABC will be equals to 180 plus 180. So the summation of all this, that is a quadrilateral. Summation of triangle ADC plus triangle ABC, that will give you a quadrilateral. So quadrilateral ABCD will be equals to 180 plus 180, it will give you 360. So this way the total angle of a quadrilateral will be 360. And now what does it means? It means that a quadrilateral is having some total angles of 360. That means individual sum, that is angle A plus angle B plus angle C plus angle D, will give you 360. Okay, this way a quadrilateral is having the total as 360. Now next is types of quadrilateral in your textbook. So how many types of quadrilateral are there? So there are total 6 types of quadrilateral. First one is a trapezium, second one is a parallelogram, third is a rectangle, fourth is a rhombus, fifth is a square and sixth is a kite. So one by one we will study all these quadrilaterals. Okay, first is a trapezium. Now what is a trapezium? A trapezium is a figure that is having only one set of opposite sides parallel. Here if you watch this figure, this is the figure of a trapezium. Now here in this figure you are having only one pairs of opposite sides as parallel. Okay, see here if I am talking about, that means AB is parallel to CD only. Why AD is not parallel to BC? Because when we will extend these two lines, they will meet at some point. So this is not possible that they are parallel. So only one pair of line is parallel, that is AB is parallel to CD only. Okay, then nothing is possible after this. Then after this figure is known as a trapezium. Trapezium. I'm writing over here so that you can understand. This is trapezium. Okay, trapezium is a figure like a night lamp. Okay, then after next figure, this second figure is a parallelogram. Now parallelogram is what? Parallelogram is having opposite pairs of sides equal and parallel. See, name only suggests that it is a parallelogram, so something must be parallel in this. So here we are having opposite sides as equal and parallel. Now how you will get opposite side equal and parallel, that I am showing you. Here this is a parallelogram. Here we are having opposite sides SR and PQ. Then next sets of opposite line is PS and QR. So here SR will be parallel to PQ and PS will be parallel to QR. This way you will get opposite sets as parallel. Okay, so this figure is known as a parallelogram. Then after next figure is a rectangle. So what is a rectangle? Rectangle is also like a parallelogram, only rectangle is a special case of a parallelogram. Remember this thing. Why it is a special case of a parallelogram? Because it is also having opposite sides as parallel. Okay, here in a rectangle we are having SR is parallel to MN, SR is parallel to MN, and SM is parallel to RN. So SR is parallel to MN and SM is parallel to RN. Okay, but how we can differentiate between a parallelogram and a rectangle is that a rectangle is having all angles 90 degree. Okay, so when you have to prove a parallelogram into a rectangle, what you will do, you will prove any one of its angle as 90 degree. Then after next is a rhombus. So what is a rhombus? A rhombus is a tilted square. Okay, somewhat tilted square. See, it is like square only, but it is tilted. Square is a straight figure and rhombus is a tilted figure. Okay, so rhombus is a tilted square. So now when you have to prove a parallelogram to be a rhombus, what you have to do? See, a rhombus, a rectangle and a square. All these three figures are parallelogram only. Okay, because they are satisfying the properties of a parallelogram, but they also have their individual properties. Like rectangle, if we talk about, rectangle is having all angles are 90 degree, it is the individual property. Then after rhombus, again rhombus is a tilted square, so all sides must be equal in a rhombus. Then after square, square is again having all sides equal and all angles 90 degree. So this way they all are parallelogram, but they have their individual properties also. So first of all, you can say that a rectangle, a rhombus and a square can be a parallelogram, but the vice versa statement is not true. That is, a parallelogram cannot be a square, it cannot be a rectangle, it cannot be a rhombus also. Okay, vice versa statement is not true. Now if we talk about rhombus, so this is the figure of a rhombus. Now rhombus is again having opposite sets of parallel lines are parallel. Then after, the property of rhombus is all sides are equal. That means here we are having total 4 sides, so that all 4 sides will be equal. DE will be equals to EF, that will be equals to GF, and that will be equals to GD. This way all the pairs of 4 sides are equal. Okay, then after, this is the property of a rhombus. Then after come to square. Then what is a square? So a square is a figure that is having all 4 sides equal and all angles are 90 degree. So angle A is equals to angle B, that is equals to angle C, that is equals to angle D, that is equals to 90 degree. Here all angles will be 90 degree and all sides will be equal. That is AB is equals to CB is equals to DC is equals to AD. This way all 4 sides will be equal. So now this is the properties of a square. Then after next come to kite. Now what is a kite? A kite is a diamond shaped figure. Okay, now a kite is strictly not a parallelogram. See, this is the figure of kite. So when you will draw a kite, it will be in this way. That is A, B, C and D. So here in kite we are having adjacent sides. That means the side next to one side. Okay, adjacent side means side next to one side. That means AD if we are taking, then you have to take AB, and if you are taking CD, then you have to take CB. This way. So the side next to these sides are equal. Okay, not parallel. A kite is strictly not a parallelogram. It is only a quadrilateral which is having adjacent sides equal. That is AD is equals to AB. I'm writing over here, AD is equals to AB and next is CD is equals to CB, this way. Okay, so these are the properties of 6 types of quadrilateral. Now you have to remember these properties to solve the sum ahead, and if you want to revise all these properties, so here it is given, all the properties are given. First is the property of a trapezium, second is the property of a parallelogram. Then on next page, this is third, this is fourth, fifth and sixth. According to your textbooks figures only these properties are given, so you can revise all these properties whenever you want to revise. Then after, next is other notes. Okay, now in other notes it is given that not that a square, rectangle and rhombus are all parallelograms. A square, rectangle and rhombus all are parallelograms. Then next is a square is a rectangle and also a rhombus, because square is satisfying the property of rectangle also and rhombus also. So a square can be a rectangle also and a rhombus also. But the vice versa statement is not true. Come to the vice versa statement. A rectangle or a rhombus is not a square. Okay, a rectangle and a rhombus cannot be a square. Vice versa is not true. Only the square can be a rectangle and a rhombus, but a rectangle and a rhombus cannot be a square, can never be a square, because they are not satisfying the property of a square. Then after, next note, a parallelogram is a trapezium. See why a parallelogram is a trapezium? Because it is satisfying the property of a trapezium. That means one side is parallel in a parallelogram. Even in a parallelogram both sides are parallel, but we can take one side parallel because a trapezium is only having one side parallel. Then after, the vice versa statement. But a trapezium cannot be a parallelogram, can never be a parallelogram. Why? Because as only one pair of opposite side is parallel in a trapezium, and we require both pairs to be parallel in a parallelogram. Both pairs must be parallel to for the figure to be a parallelogram, but here only one side is parallel, so the vice versa statement is not true. Then a kite. A kite is not a parallelogram. It is strictly mentioned over here. A kite is not a parallelogram because we are not having any parallel sides in kite. We are only having adjacent sides in kite, and that are also not parallel, that are equal. Okay, so a kite is not a parallelogram. Then after, next is properties of a parallelogram. Now what are properties of a parallelogram? We will study one and each property of a parallelogram in the form of a theorem. Okay, we are having up to theorem number 8.10 we are having. So there we will study one by one each and every property of a parallelogram. So first theorem, you have to prove that theorem, that is theorem number 8.1, and an important theorem. Okay, now what is the statement of this theorem? That is, a diagonal of a parallelogram divides it into two congruent triangles. That means if we are making a parallelogram over here, suppose this is a parallelogram ABCD. Okay, and if we want to draw a diagonal in a parallelogram, that is diagonal AC. So what will happen, as soon as you will draw this diagonal, it will divide your parallelogram into two triangles, and that triangles must be congruent. Congruent means they must be equal in all aspects. That is, all sides must be equal, all angles must be equal, areas must be equal. In all aspects, these two triangles will be equal. So triangle ADC and triangle ABC, you have, first of all you have to prove congruent, then after you have to prove that a diagonal of a parallelogram divides it into two congruent triangles. First of all we will prove these two triangles as congruent. So triangle ADC and triangle ABC. So I am making a figure of a parallelogram over here so that we can have it for our reference. A, B, C and D. Here we are having diagonal, that is diagonal AC. Now in triangle, we want to prove that triangle ABC are congruent to triangle ADC. So we will take this to triangle in triangle ABC and triangle ADC. In both these two triangles, what we will prove? We will prove these two triangles are congruent. So first of all we can take, see first what you can take. So first you can take alternate angle. Here angle DAC is equals to angle ACB. This way Z is forming. So here these two angles are alternate. So I am taking here angle we are taking triangle ABC first. So you have to take first angle of that triangle only. So angle BCA, that will be equals to angle CAD or DCA. Okay, and the reason is alternate interior angle. Why these triangles are equal? Because alternate interior angle. Then after, next is side AC. Side AC is common in both, so AC is equals to AC, and there you will write because these sides are common. Then after, next what is that? So next again an angle is there. Now which angle? So again alternate interior angle, that is if AB is parallel to CD, because it is a parallelogram, so AB is parallel to CD and AD is parallel to CB also. So we can take again one Z, and where that Z is, so this is in this way. Okay, this way. Here D is there, here C, here A, and here B. So this angle is your Z. So here we can take angle D, angle B, AC will be equals to angle DCA. Again the reason will be same, alternate interior angles. Now if these are alternate interior angles, so now which criteria? So criteria you have to see. So now first is angle, second is a side, and third is again an angle. So the criteria is angle, side, angle. Okay, so here triangle ABC is congruent to triangle ADC by which criteria? So by angle, side angle criteria, this triangle is congruent. Now if the triangle is congruent, you can say that diagonal AC is dividing your parallelogram into two congruent triangles, that are triangle ADC and triangle ABC. So this is only the proof. You have to read this proof from your textbook. Everything is given in your textbook only, and this is the important theorem. One might ask you this 3 marks. Okay, this theorem can be of 3 marks in your exam, so prepare well. Then after, theorem number 8.2, in a parallelogram opposite sides are equal. Okay, if we are having a parallelogram, so in a parallelogram opposite sides can be equal. If I am making a parallelogram over here, that is this way, A, B, C, D. Okay, so pair of opposite sides are parallel, but along with parallel they are equal. So AB will be parallel to CD and AB will be equals to CD. Then this side AD will be parallel to CB, BC, and AD will be equals to BC. This way, if sides are parallel, then they are equal also in a parallelogram. That means in a parallelogram opposite sides are equal. See, for each and every theorem you don't have to prove it, you only have to write the statement in which in your textbook the theorem whose proof are given, you only have to prove that only. Okay, next you have to just read it and remember the statement only. Then after, next theorem number 8.3, if each pair of opposite side of a quadrilateral is equal, then it is a parallelogram. See, each pair of opposite side, each means one by one everything. Okay, each means 1 to 1. So each pair of opposite side of a quadrilateral is equal. Each pair of which side? Opposite side. Okay, so if we are making a quadrilateral A, B, C, D. Now what they are saying, this is a quadrilateral. Now each pair of opposite side, if it is equal, that means AB will be equals to DC and AD will be equals to BC. If this situation exists, then this figure of quadrilateral, it will be a parallelogram. If this type of situation is there. Okay, if opposite sides are parallel, then this figure will be this quadrilateral will become a parallelogram. Then after, next theorem, theorem number 8.4, that is a parallelogram. 1 minute. Yes, theorem 8.4, a parallelogram, in a parallelogram opposite angles are equal. Okay, so now opposite sides are equal only. Now next is opposite angle. What about opposite angle? So in a parallelogram opposite angles are also equal. Then theorem number 8.5, if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. If we are having any quadrilateral and in that quadrilateral also if opposite angles are equal, then that quadrilateral will behave like a parallelogram. Then after, next is theorem 8.6, the diagonals of a parallelogram bisect each other. Now what do you mean by bisect? Bisect means dividing into equal half, okay, dividing into two equal portions. So the diagonals of a the diagonals of a parallelogram bisect each other. Bisect means if we are having one parallelogram A, B, C and D. So the diagonals, when we will make the diagonals, that is AC and BD, at O we will make. So here the situation will like AO is equals to OC and OD will be equals to OB, because they are bisecting. Okay, so the diagonals of a parallelogram bisect each other. Then next is theorem number 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Again, if we are having any quadrilateral and in that if the diagonals are bisecting each other, then that quadrilateral will behave like a parallelogram. Then after, next is theorem number 8.8, that is on page number 145. Another condition for the quadrilateral to be a parallelogram. Now what are the another conditions? So theorem number 8.8 is a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. When will a quadrilateral will behave like a parallelogram? When the pair of opposite sides are equal and parallel. Opposite sides must be equal also and must be parallel also for the quadrilateral to behave like a parallelogram. Then after, next we are starting with the exercise, that is exercise 8.1. So I will explain you with the PDF of the solution. In solution PDF only I will explain it to you.